Hi, it is the second part of section 3.2. Here we'll consider problems and issues with the Perceptron algorithm. The first one is with inseparable data sets. Once the data is inseparable, then there is no guarantee for convergence or accuracy. Look at this example. The perceptron is updating iteratively with each time a single data point. So here in this data, this one and that red box are noise. So that when it is used, the perceptron may produce weight such that the corresponding line, separating line is this one. And when this data point is used, then the weight may change so that the corresponding separator is that. So the perceptron is most likely oscillatory. It's not converging. The data is not separable. So it's oscillatory. In this case, you may try to use an averaged perceptron, and then it can be better. You can average the weights vectors across all or last part of iterations. And at the last part, for example, it's oscillating back and forth with these two separators. Then by averaging them, you can get the final one. Here, frequently the training data is linearly separable. One of the main reasons is that the number of data points is much smaller than the number of features. In modern society, big data is a really hard issue. However, in machine learning, each data point is related with money, so that for new the classification area, usually number of data point is not really not large, so that looks like separable. With those data set, perceptron can significantly overfit the data. To avoid this overfitting, you may again apply averaged perceptron. Then you can escape from overfitting partly. And now here, this is overfitting the result. For test data through iteration of updating along with the perceptron, here accuracy, okay, for training, the accuracy is increasing all the way, so that through training, you can get really good accuracy. However, for some test set, and from a certain moment, now the accuracies go down. So that if the difference is large, then it is a sign of overfitting. So it is fitting for the data point well. However, it's not well generalized for unseen data. So in this case, we can say it is overfitted. And tested data or held out data. And now, from time to time, you will see in holdout method. Okay, holdout is when you split your data set into a training set and a test set. The given data set is separated, and the training set is used to model training, and the test set is used to see how well that model performs on unseen data. So unseen data is really unseen so far. So part of the data set will be used to for unseen data. So that is called holdout method. And here, that test means that using some other data set, and it is tested anyway in this way, and it's predicted, and now as more along with more iteration, the model is used, and later on the accuracy is broken, and from a certain moment it's overfitting appeared. Okay. Now second one is now optimal separator. If it is separable, then the perceptron will converge, and this one of these linear separators, and every of that lines are separating the data set perfectly, so that here when you are trying to find the weight vector, then depending on your initialization and depending on the use of data points, and your algorithm will converge to one of them or something else, so that separating the data set. But the question is, which one is optimal? And one way to get optimal separator is related with the so-called support vector machine. And the method chooses the linear separator with the largest margin. And among the separators, it is choosing a separator such that the margin is largest, so that later on new points are coming in, then it can be better generalized. That means it can be better performed for unseen data set. Okay, we'll deal with this one in chapter 5. And now, what if the number of classes are larger than 2, so that we have to deal with multiclass classification. In this example, in this picture, we have 3 classes. Now, ideally, we can separate out with this in this way, but our algorithm is making a line so that here to get such a separation classification, one stated is 1 versus all, or sometimes it's called 1 versus rest. And that means that we try to train 3 weights, and then minus data versus 0 and plus. That is now W minus. So here one side just the minus data, and other points on the other side. Of course, because of that, and it's not really perfectly separable. However, now minus versus 0 and plus, and second one is plus versus an O and minus, and now O versus plus and minus. So we can make here 3 separators, and then in prediction, you are measuring along with each separator W minus, W plus, W zero for each of them for given sample. you are making here now weighted sum and activation, then now in this case it'll have three values. Now minus, plus, 0. Among them, we try to choose the largest one, and the index will be chosen. So that means that, for example, point, okay, the new point x is, for example, here. Okay, here is the new point x. Then, now, here, that is minus versus else, the rest. Here, that is, this line will be 0, and this is negative, and this is positive. And now for positive versus else, is now the value is 0, is positive here, this is negative. And also, the O versus else is now along the line is 0, over the positive, this area is negative. So that for every of these three, the activation, the values will be negative. However, among them, now this is nearest, so that if it touches this line, then now it'll become 0. But near to this red line, so that along with and minus versus rest, the value will be largest. Negative for every separator, the activation value, they are negative. However, this one is the largest one among these negative values. That means that now it can be classified for here negative class. So eventually, along with that strategy, you can make here now the bisect the angle, and here also bisect the angle, and bisect the angle like that, and it'll meet here. So eventually, the net effect, net classification is happening like this three regions. Okay, that is called here one versus all, or one versus rest. For general number of classes, you can apply this technique. Okay, that's the end of section. Thank you.